Okay, the next problem. A spotlight on the ground shines on a wall 8 feet away. Oh, come on. Wall. And this is 8 feet away. Spotlight. It shines some light. Okay. A lemur that is half a foot tall is walking towards the wall. So if I call that x, dx dt is 2 feet per second. Okay. When he is 6 feet from the light, when he is 6 feet, if he's 6 feet from the light, that means x equal 2. So when x equal 2, oh yeah, 2 feet from the wall, how fast, call this the shadow y, what does dy dt equal? Well, here we need an equation. That turns out to be the challenging part. Oh no, right there. Okay, good. Well, let's see. If I take y divided by the 8, that is the 1/2 divided by, if the whole thing is 8, and I call this x, that will make this 8 minus x. They must add up to 8. And if I multiply by 8 both sides, and if I take a derivative, dy dt is 4 divided by 8 minus x squared dx dt. And that is 4 over x is 2. So 8 minus 2, that's 6 squared. And the x dt we said was 2. So dy dt is 8 divided by 36. Divided by 4, that's 2 over 9. And the units are feet per second. All right. I should have moved all of that. That's okay. All right, here's a graph. The graph of a function represents s of t, which is the position of a function. Okay. At t equal negative 3, t equal negative 3 is right there. Is the object acceleration positive or negative? Well, let's see. Isn't that graph concaving down to this point? Right? Then concaving up to this point. Then concaving down to this point. Then concaving up. So, since the function is concaving down, that means the acceleration at negative 3 is negative. Remember, if the second derivative is negative, the function is concaving down. And if the second derivative is positive, the function is concaving up. Okay? On what intervals does the object have both positive velocity and negative acceleration? Okay, negative acceleration means concaving down. Concaving down, I already labeled them. They're marked in yellow. Positive velocity is positive if the function is increasing. The function is increasing on the yellow part only from -4 or -infinity to -2. Then here it's decreasing. it's increasing, but this doesn't count because the negative acceleration is concaving down. Concaving down begins from here, from this point, from 1 all the way to this point, because after that you're decreasing. So F is decreasing. Of course, it's increasing here, but it's not concaving down, which is negative acceleration. So the answer would be just from -4 to -2, and from 1 to 2. X equal that is. Okay, next problem up. We have two functions. 5 minus x squared is an upside down parabola. That's this one. X squared plus 3 is a parabola opening upwards. That's this parabola. Label the curve by their equation. Where do they intersect? Where does x squared plus 3 equal 5 minus x squared? That's when 2x squared equals a 2. X squared equals a 1. X equal plus or minus 1. So this happens from -1, and this happens from 1. Set up, do not compute, an integral that will find the shaded region from -1 to 1. I'm going to run with respect to x, meaning we're running vertically. I notice that over this interval, the top is the purple, and the base is the orange. And that'll do the trick. That will find me the shaded area. Here's another problem. Setup, do not evaluate. This is x into 8 minus x cubed. So this is 0, and this is 2. And this is the graph simply of y equal 8x minus x to the 4th. They want us to find the volume rotated about the x-axis in the first case. So this is going to create an identical copy like it. It's going to look something like this. It's going to occupy that. So here, solving for x is a bit trickier than we like. We're going to go with it. And I altered the problems where I include the shell and the washer, both methods. In this case, we're going to pick our rectangles perpendicular to the axis of rotation. If that's the case, we're going to create a solid disk that looks like this. Where I could tell the radius starts right there at 0, and we always go to the original. This distance is top minus bottom. This is 8x minus x to the 4th. And since this is all come on, okay, here we go. And since this is a solid, there's no gap. Volume is simply the integral from 0 to 2 of the area of this, a of x, pi times 8x minus x to the 4th squared dx. Done deal. If I was to take this problem, same problem, and rotate the graph about y equal -1, then this would create an identical copy like it, and it would look something like this. Now, that is 8x minus x to the 4th mistaken. Yeah. Okay. As this rotates, if I pick my rectangle perpendicular to the axis of rotation, now I notice I have what's known as a washer. It's not registering for some reason. Really quick. Here we go. Where, remember, I'm rotating this about the line y equal -1. This point is this point, and this distance is top minus bottom. It is 8x minus x to the fourth minus a -1. That's that radius. And I notice there's a hollow part right there. Where this distance is simply top minus bottom. 0 minus a -1 is 1. And all what I want is to find the area of that washer. Well, volume is going to be the integral. We're still running from 0 to 2. We're still running vertically because my rectangle is vertical. I'm going to take the whole outer area, pi times 8x minus x to the fourth minus a -1 squared, minus the inner area minus this area, which is pi times 1 squared. And be careful not to combine the radii in any way. And that's basically all there is to it. Vertically, we take top minus bottom, horizontally, right minus left. Now, I altered the next problem so it matches all the combinations, because I think, they did this hasty and they didn't see it really. They don't. I'm changing this to the y-axis. If I was to take this graph and rotate it about the y-axis, here we're rotating about y equal -1, x-axis, y-axis. This will create an identical copy like it right there. This is still y equal 8x minus x to the fourth, right? And that's going to occupy all of this. Now, if I pick my rectangles parallel to the axis of rotation, it's going to create an identical copy, and there is my cylindrical shell. Volume is the integral of 2 pi times the radius, the height, the thickness. Here I picked it vertically, so it's dx. I am running from 0 to 2 still. Now, the catch, I will always go to the origin and run to wherever I picked my rectangle and call that x. And you see, based on the diagram I did, the radius is x, and the height is top minus bottom, 8x minus x to the fourth minus 0, and there it is. Done deal. And what if I was to take that and rotate it about the line? Okay, that didn't work. What if I was to take that and rotate it about the line x equal -2? Then that is going to create an identical copy like it right there. I pick my rectangles, and this is going to create a copy like it right there, and there it is. It's still a cylinder, and I can see it clearly. Volume equal the integral, still 0 to 2, the original, 2 pi, the radius, the height, and since I picked it vertically, the thickness is delta x. Now, I'm going to run from the origin. There's the origin. I'm going to call this x. But do you notice that is not the radius? The radius is actually this distance, right? Minus a -2 is +2. The height remains the same, top minus bottom, 8x minus x to the fourth. There it is. Nothing to it. Let me adjust the last piece. Okay, I just adjusted the last piece. Now let's see how this works. Setup, do not evaluate the volume. Okay, they're talking about y equal 9 minus, it's right there. That is y equal 9 minus x squared. Y equal 12. There is y equal 12. X equals 0 and x equal 3. Okay, very good. We're going to rotate this about the x-axis. That's going to create an identical copy like it right there. Right there. And right there. And it's going to occupy that much. If I pick my rectangle, do you see why I want it vertical? Because the top is always the orange and the bottom is always the purple. Then I'm going to create a washer again. The radius of the washer, this point is right there. This distance is top minus bottom. That's simply 12. And the hollow part happened to be right there. That's the part that's empty. You consider that a circle. This distance is this distance. That is 9 minus x squared. And I want this area. So volume is going to be, I'm running dx, which means x equals 0 to x equals 3. And it's going to be the outer area, pi times 12 squared, minus pi times 9 minus x squared squared. There it is. Done deal. Last problem. I'm trying to figure out the integral. Now, I know the graph doesn't look like that, but if you really just entertain that areas work this way, this should do the problem. Again, this doesn't really resemble this specific problem because here they're saying some areas positive or negative, but altogether, I'm running from -2 to 6 to 11. Let's say that is -2, 2, 4, 6, 10, 12. So suppose you have the following, y equal f of x. From -2 to 6, yeah, to 11. So here's the deal. If I integrate from -2 to 11 f of x, can't I say that's the integral from -2 to 6 plus the integral from 6 to 11? Well, I know this is -7. I know this is 9. Can't I figure out what the integral from 6 to 11 is? Can't I say -16 is the integral from 6 to 11 of f of x dx? So basically, this is what we're saying. If you take this area and add it to this area, that should equal the total. So now I'm looking at what is it they want. I would say that's twice the integral from 11 to 6 of f of x dx, property of integration. And what's the price for switching the limits and the intervals? Do you recall? The limit from a to b. If you switch b to a, Don't you multiply that by a negative? And wouldn't that be a -2? And this quantity I know is already a -16, so that will be a 32. And if I look at this problem, that's -2 to 6 of 3g of x dx plus the integral from -2 to 6 of 7 dx. Again, properties of integrals. That is 3 times the integral from -2 to 6 of g of x dx plus, isn't that 7x evaluated from -2 to 6? -2 to 6 g of x dx is a, okay, now it doesn't want to register. It's a 5. And isn't that 7 times 6 minus a -2? Wouldn't that be 15 plus 7 times 8? 15 plus, what is that? 56. 71. If I made any error in calculation, don't be alarmed. I do that sometimes. Just worry about the setup of the problems and how they work. All right, again, this is a lot bigger than our final. Our final is a lot shorter than this, but this covers all the topics that we had.